All right, a bit of differentiation for you now using the three big rules, the product rule, the chain rule, and the quotient rule. So looking at part A, we've got a function multiplied by another function here. So the product of two functions requires the product rule to do the differentiation. The product rule is if you've got a function u times a function v, then dy dx is u times dv dx plus v times du dx. So I'm going to take u to be our 3x squared. So therefore du dx is 6x. And the v is e to the 2x. So dv dx is 2e to the 2x. When we pop those things into the formula for the product rule, we get u, which is this, times dv dx plus v times du dx, which gives us this. Now, we could leave it like that, but I'd prefer to factorize it so that it looks a bit neater. And the common factor is 6x e to the 2x, and what we're left with is the factor of x plus 1. This is more useful if we're trying to find turning points, for example. Once it's factorized, it's much easier to find when dy dx equals 0. Okay, so for part B, we've got a function of a function of x, a function of a function of x. So this requires the chain rule. So we say u equals the thing inside the brackets. U equals cos 2x minus sine 3x. Differentiating that with respect to x gives du dx is minus 2 sine 2x because cos differentiates to minus sine, and then minus 3 cos 3x. Then y, if u equals this thing here, then y is now equal to ln u. And then dy du, differentiating y with respect to u, gives us 1 over u. So that's the preliminary differentiation. Now I can bring those two together with the chain rule. So the chain rule says dy dx is dy du multiplied by du dx. So dy du is this, and du dx is that. So there we are. U 1 over u, but u, remember, is cos 2x minus sine 3x. So there's the 1 over u multiplied by the du dx on the top. Okay, so part C, we've got a function divided by a function, an algebraic fraction. So we could use the product rule, but I'm going to use the quotient rule. If we could use the product rule, if we expressed x cubed plus 2 as x cubed plus 2 brackets to the minus 1, and then we could do the product rule. But I'm going to use the quotient rule. So the quotient rule says that if y is a function of u divided by another function v, then dy dx is this thing. So I'm making v the x cubed plus 2. So therefore dv dx is 3x squared. And my u is this thing. So we've got to now differentiate this with respect to x. Differentiating that is straightforward, that is straightforward. But here we've got a function multiplied by a function. So we need to use the product rule again here. So using the product rule gives us x cos x, u times dv dx, plus 1 times sine x, plus v times du dx. So that's together is the differential of x sine x, and then we've got to differentiate cos x to minus sine x and x to 1. So now we've got u and du dx, we've got v and dv dx. We can put all of those things into here, rather messy. Just before we do that, of course, this expression simplifies, thankfully, to x cos x plus 1. Then when we put those things into the expression for dy dx, we get dy dx equals v, which is this, times du dx minus u times dv dx over v squared. Not going to spend any time simplifying that. It's complicated enough as it is, and actually I don't think it does simplify anyway. Okay, so there we are.